Hello. In today's video, we're going to be talking about the second derivative test. This is the last part of lesson 4-3, which covers the variety of things we can use the second derivative for. The second derivative test stands in contrast to the first derivative test, which was also about finding relative max and mins, relative extrema. The first derivative test is synonymous with making a first derivative number line and evaluating the increasing and decreasing behavior to determine whether the function has relative maxima or minima. However, this test does not require a second derivative number line, nor will this test have anything to do with finding points of inflection. Again, it is only used to find relative extrema, maxes and mins. It's going to be a quite simple procedure. We are going to still use f prime to find the critical numbers. Critical numbers will still be the only possible locations of relative extrema. Then we're going to use the critical numbers in f double prime to analyze concavity to determine if the function has a relative maxima or minima. The idea is, if f double prime is positive, that means our shape locally is concave up. And so when we add this with the fact that we have a critical number, we are talking about being a relative min. Whereas, in a similar fashion, if f double prime is negative, we will have a concave downward shape, and combined with the fact that we are a critical number means we'll have a relative max. And that's really all there is to this test. We will note that this does not give an answer when f double prime equals 0. That is to say, if f double prime equals 0, we will say the second derivative test is inconclusive. Not possible to determine, however you want to write it. We will use the second derivative test only when the directions require it or when the given information requires it. We will do one example when the given information requires it. However, I would be remiss to fail to point out, I need to point out that the given information requires it, especially for implicit differentiation situations. If we use implicit differentiation, the number line is not possible because two things are varying at once. If my first derivative depends on x and y, a number line is not possible, so we will have to use this test, the second derivative test. Be careful. Without further ado, use the second derivative test to find the relative maxima and minima of this graph, the points. So again, this is a relatively simple situation. We are being told directly to use the second derivative test, so we will not think about using the first. Again, the first derivative test is a number line. You should be able to do that on this function pretty easily. However, since we're being asked to use the second derivative test, we will start by taking the first derivative and it really needs to be this simple for you to take this derivative at this point. We need to find the critical numbers, which are the values of x that would make f prime of x equal to 0. So we'll factor. I'm going to factor out a negative 12 because the negative is a leading coefficient, and it usually makes things easier to have a positive leading coefficient. And then we have a difference of squares here And the only solutions to this equation are 0, 1, and negative 1. Critical numbers can also be found when f double prime of x is undefined, but because f prime of x is a polynomial, we have the fact that f prime of x, f prime of x, it's a very important distinction for a problem like this, f prime of x is never undefined. So we have three critical numbers, 0, 1, and negative 1. I'm actually going to write this as x equals to keep in form if I normally write this. So now that we found the first derivative and we found the critical numbers, we're going to have to look at the second derivative by taking the derivative of the first derivative. Looking at that equation, we're going to substitute or plug in these three critical numbers. So f double prime of 0 is negative 12, positive 12, sorry. That's a positive number, which means we'll have a relative min at x equals 0. That's as simple as it is. A positive second derivative means we are concave up. F is concave up. F is concave up, and we have a critical number. It means we're right down there. A horizontal tangent line only at the bottom. F double prime of positive 1 would give us negative 24, which is of course a negative number, which is a relative max at x equals 1. Finally, f double prime of negative 1 also gives us negative 24, which is still a negative number, so we will have also a relative max at x equals negative 1. Now this problem asks me for the points on the graph. So again, we are going to use f to find the y values at these points. So my relative maxima, plural, we would have 1 into f, which would give me 3, and negative 1 comma 3. And my relative minimum, singular, would be the point 0, 0. And again, these y values come from the function itself, come from f itself. It is very easy to get confused when using the second derivative test. We've had to use all three functions at various points. This is why we will use the first derivative test unless we have to use the second derivative test. When would we possibly have to use the second derivative test? Well, that's in a situation like this. Here we do not have an explicit definition of the function. We only have data about the function. We only know certain things about the function. There is no way to derive a formula for the first derivative, so there's no way to find a formula for the second derivative. There's no way to make a number line. You're really stuck. We can assume that we don't know. Pretend that you're taking this question on a test and you get lost and you have no idea what to do. Either way, whether we're finding the relative maxes and mins with the first derivative test or the second derivative test, we will have to find the critical numbers of g. So finding the critical numbers here would be the values of x that make g prime 0 or undefined. And again, we are very lucky, wink wink, that we have the four values up here are all telling us that g prime is equal to 0 at these four x values. So we know critical numbers. Specifically, we have -3, -1, 0, and 2 are all critical numbers of G because they are all x values that make G prime 0. That's it. So maybe you think now, okay, let's make a number line. That will not work out well. I'll show why at the end, just to be clear. What will work out well is noticing the second sentence here where they start talking about the second derivative of G, G double prime. Those those values are hinting at that we will want to use the second derivative tests. So since G double prime, I'm going to plug these numbers into G double prime. G double prime of -3 is 4, so that's positive, a relative min. G double prime of -1 is -2, which is negative. That's a relative max. G double prime of 0 is 0, and again, whenever we have a 0 in our second derivative, we would say this is inconclusive. This tells me nothing about whether it's a relative max or min. We just can't decide. And finally, G double prime of 2 is 3, which is a positive number, or it's a relative min. So they're asking for the x values of relative max and mins when possible. I would say my relative maxima, I have one at x equals -1. I do not know the y coordinate. Do not assume this is a y coordinate. That would be wrong. Do not assume this is a y coordinate. That would be wrong. They are not y coordinates of G. And I have two relative min locations, one at x equals -3 and one at x equals +2. Be careful, again, not to use these values, and certainly not to use the zeros. And that would be my final answer. So the main trick in this problem is ignoring the distractor information, specifically that G double prime of 1 equals 5. The second derivative at G, at 1 of G, is positive. That does not mean we have a relative max or min. Remember, a positive second derivative is only indicative of a relative max or min when it is paired with a critical number. To show what we're talking about here, you could have a positive concavity at 1. That certainly is a positive concavity, certainly concave up at +1. Yet this point is certainly not a relative max or min. We just don't know without knowing that it is also a critical number. It could be, but we just don't know. So again, you want to be careful not to use the distractor information. Finally, if you thought the right thing to do here was a first derivative number line, you would get this far. You would make a G prime number line. You could throw on your critical numbers. But now the next step for the first derivative test would be to test the sign of G prime between, say, 0 and 2, or 0 and -1. But we have no way of finding the signs here. Absolutely no way of finding signs. We cannot use any of this fact to determine the signs of G prime. G double prime is a completely different function. So we are just lost. That will get us nothing. I've seen students in desperation put pluses and minus. You don't get any credit for that. You might get credit for identifying the critical numbers, but make sure you label it as such. So again, the big giveaway here for the second derivative test is the words relative maxes and mins, which narrows it down to first or second, and then the fact that we have second derivative information. So now you should be able to do every single problem in 4-3. Good luck, have fun, and let me know if you have any questions. Have a great time. Bye for now.